Those limits don't get to stay at A and B, they get to change to U of B and U of A. Okay, remember, U is a function. It might be 2 theta, like Maggie's problem right here. It might be inverse tangent, like Lauren's right here. Okay, so then the U of something is, well, let's plug that in. So that's a big change. The other big change is a nice change, and that we're done with the U. We don't have to go back to the U. Okay? Once you've changed the limits, you are now dealing with an integral with a U limit, then you should be done with the X. Okay, so here we go. What does U equal in this problem? We did it last class. What does U equal, Lydia? 2x plus 1. Okay. So 2x plus 1 is U. We already know that works. So du dx, the derivative is 2, and du is 2 dx. Okay. We don't have a 2 to substitute in, so we're going to divide it out. And we're going to have 1/2 du equaling dx. Okay? We have a dx. All right? So we are going to swap the dx for 1/2 du. Okay? This became that. I'm pretending like I don't know that the 1/2 is going to go out front for now, but that's where it's going. Yes?
When we're writing, like, solving, we want us to have that step in there.
No, it is not necessary. Okay. Using a property of integral, this is where this is going to go, and I'm quite certain that most of you are already there. Okay? But in case you weren't, it's okay not to be there. All right. Now, what do I have left inside this? The dx is gone. Okay, what do I have left? Radical u. Radical u. Okay? All right. Everything that's been replaced is in red. The black is. Now, the last thing I need to worry about is this guy. This is no longer 0. It's u of 0. And this is no longer 4. It's u of 4. Okay? Now, u of 0, let's take a look at it over here. That means put the x in, put 0 in for the x. What is that? That's 1. So there's 1. And the u of 4 is what?
9.
9. Okay. So that's 9. Now, do not put 4 and 1 over here, because if you do, that's wrong. Put u of 0, and then you'll remember, oh wait, I got to plug that 0 in, and put u of 4, or switch it right away, but don't put 0 and 4, because you'll forget it. Oh gosh, you have to fix that, and then you're screwed, because you're not going to get it right. Okay, now, square root of u, what are we going to use for that, Abby? We're not going to use square root of u. What are we going to use? Right here. Before I can, what would you change that to?
U to the 1/2.
U to the 1/2. Give me a blank stare there for a moment. All right, now what am I ready to do? Sophia has a question.
No.
Okay, go for it. What am I ready to do? Give me the words. Integrate it. So find the. Okay, here we go. All right, what is the antiderivative, Miss Sophia? All right, nice. We're dividing by 3/2, which is multiplication by 2/3. Good job. Now, this 2, there's no point in hanging that around. Just cancel it out. So really, I have 1/3. Now, notice I didn't do the C. We don't have to do C on definite intervals, right? But I do have a 1 and a 9 that I should put up there. That reminds my brain that, oh wait, I gotta plug those in now. Notice we're not going back to plug in our x. We're just gonna plug in our new limits 1 and 9. Okay, so the 1/3's taken care of. We have 9 to the 3/2. Right, when I plugged in that 9, what else do I have inside there? Kizzy, right? Nice. Okay. So that's plugging in the 9 and plugging in the 1. All right, now it's just evaluating. Once you have changed the limits again, you are done with the x on the definite intervals. Okay, so what is 9 to the 3/2 power? Square root of 9 to the 3rd power, right, Jenny, is 27. 1 to any power is 1. All right, so what's that number? 26 over 3. I'm done with it. Okay? Remember, definite intervals you can check out because I know you want them all right when you show up to class. If this was not one that you could check in the back of the book, then you could check it on your calculator. It takes a minute, but math 9 is an integration. You're going to put in the first one, not this one, because that's the one we got to make sure. So the math from 0 to 4 of radical to x plus 1, close your radical in terms of x. 26/3 is that decimal. Okay? All right. If you put in the other one, I forget what it was. This one, 1/2. Let's see. 1/2. Math 9. What was it? 1 to 9. We got to use x to the 1/2. It will give you the same answer, but I would start there to check because sometimes you might have made a mistake in that calculation. But either one of them will check, so you are good to check either one of them. Your best bet is to check the original one, though. Okay, any questions about the process? Anybody? All right, let's try another one then. Okay, we got 1 to e, the integral of 1 to e of ln x over x. All right, so we got to come up with what we think is u. Who wants to throw something out here? ln of x. All right. If you're thinking ahead, you're thinking, okay, will that work? Well, it'll work if the derivative of ln x is there. What is the derivative of ln x? 1 over x. I believe that's there, is it not? All right. So this is what we're going to replace with, let's see, du. Oops, I'm green. All right. Okay, what do I have left inside there, Elena? This is gone because it's been replaced. No, I don't. U is ln of x, darling. So what's u? What? Because this, if this is gone, ln of x is sitting there, but ln x is now what? Okay, so what's inside there? U. ln of x is right here. You just told me ln of x was u, so you replaced it. You replaced this with this. Done. Simple.
On the top.
Wherever it ends up. Because remember, this is a mess right now. Let me reiterate here. This really says this, correct? Okay, so we are going to rewrite this with du, right? And we're going to rewrite this with u. Okay? So it depends. Sometimes the u is up top, sometimes it's the bottom. It just depends on what you're after. All right, now I'm not going to write 1 over e. What am I going to write here? U of 1 and u of e. All right. U of 1 means ln of 1. What is ln of 1? 0. U of e is ln of e. What's that? 1. Okay, so my new integral is what? On. What's my new integral? Everything plugged in. 0 to 1. Very good. Okay. Now I'm ready for my antiderivative, Lily Schlog. Not my derivative, my antiderivative. There you go. U squared over 2 from 0 to 1. Okay? When you're looking at the integration sign, you have to find the antiderivative to get rid of it. And I know I said this yesterday, and I know you just think I'm like anal about my notation, but because it gives you a hint of where you are in the problem. Okay. All right. If you want to pull this 2 out, that's the same as this. It's not that big a deal if you don't this time. Okay. So what's next? What do we have to do next to solve? Notice the x is not coming back in the picture. Once we've changed the limits for u, we're done with x. What do we do now, Lawrence Baldy? Nice. Okay. And 1 squared is, and there you have your answer. Okay. So you can easily check that. Any questions about the process? Anything you need to hear again? You gotta watch your original problem, you know, swapping out things, and then those are the new numbers there.
So once you put u and like the du one, okay, it stays u.
Right, for definite intervals, yes.
You're plugging it in. Right. Well, I mean, like, you know, you plug in the limit.
Right, because you basically just changed it, and once you change this to accommodate u, you're going to change the limits, and that way you're forever done with x.
Okay.
And that's the biggest, I keep saying that because that's the biggest mistake is people will go back to the x. Yeah. Well, it works, but it's just way more work because you got to plug in twice instead of just one and done. All right. Anything else? Okay. Let's see what's next. Just more practice. All right. Let's do a little bit of practice. We'll kind of pick and choose here. Let's try number 4. All right. Number 4. I'm just going to make it in page here. Yes. Some of them are.
Why do you have so much integrity?
Wow, that's nice to hear that, Lizzie. Yeah, it's fine. We're not going to do them all. Oopsie, did that wrong. Let me just try that again.
That's a cursor, right? On the right side of the problem. Okay.
know.
On number 4, there's
Yeah.
a line.
Yeah.
Okay.
That's a snip from. All right. Okay. I think you should be ready for it by yourself.
Yes, do it.
All right, do it. Then we got some more notes. We're going to go back there, but. So this is number 4 on your handout. I'm going to throw up the calculator so you'll know when you know here. Maybe. It'll be done by the time I get it plugged in, so. But all right.
What is you or me?
Supposed to be 0. Isn't it? That's that number.
Oh, it's 1 plus 1.
Isn't much as 2.
You should be in. No, but
So, that's not. Is it? Oh, yeah. It is. Okay, sorry.
but like that's you. That's where I plug in these, correct?
Yes.
You get 1 plus 1, which is 2, and then 1 plus.
Oh, for 1.
Okay. Anything that's 0 is 1, so it's 2 to 2. But so is that a problem that you have like?
That's probably need to be, okay. So 1 plus 0 is 1. 0 to the 1.5 is 0. Not.
Oh, I was thinking like I was doing it backwards.
Yeah, I would have got that because that interval would have been 0. Right. Got it? All right. Okay, so what use for you? Who had success here? You don't know. You should know whether you had success or not by the answer. Did you get the answer? Oh, she's not done. Okay.
Yeah, can we wait?
Yes, we can. Here. All right, so u equals 1 plus x to the 1.5. Now, why is that a natural choice for you, everybody? It has lots of numbers, okay. It's the most innermost part of the composite function, right? Okay, so that usually works. So what's du? 1.5 x to the 0.5 or 1/2, okay, dx, right? I skipped that middle step. You're not there. Now, I don't have a 1.5. I have the x to the 1/2, right there it is. Okay, so I'm going to divide by 1.5. Yeah, that's 1.5, isn't it? Okay. All right, and then when I divide by 1.5, I'm dividing by 3/2, which means I'm multiplying by 2/3. See how smart you are? Last year that would have caused you problems. Okay, I have this right here. Okay, so that's what I'm swapping out. So I am going to 10 is coming here. There's no point in putting that in my integration because I just don't want to deal with it. I'll deal with it later after I get my antiderivative. This x dx gets replaced with 2/3 du. I lose anybody? Okay. And what do I have left? On the bottom, so I need a 1 on top because I threw my 10 out. What's on the bottom? U squared. Okay. Now, I need to also change my limits. U of 0 and U of 1. All right. What's 2/3 times 10? Hello, 2/3 times 10. 20/3, okay. Integration, what's U of 0? 1. What's U of 1? 2. Okay. U, whatever U squared probably should be written differently as U to the minus 2. Okay. Now we are finally ready for an antiderivative. Okay. So, I see a lot of people fixing mistakes. What kind of mistakes did you make? I want to hear about them. Just ignore the top part, okay? So the 10 got totally lost. Okay. Okay. Say that again. Okay. Okay. What'd you do? And so, I mean, it's not a problem. It's just easier if you pull it out. You probably get it. It's not a problem if you don't. Okay, so 20/3. I need antiderivative. What's my antiderivative? Okay, over -1 is the same as multiplied by -1. So, okay, again, I'm going to pull that -1 out. This -1 is coming out. I always try to pull out my constants because then they're not involved in the function piece, and it just makes it easier. Okay, so you can do whatever, but you want to be like me, pull out the constants. Just okay. So 2 to the -1 minus 1 to the -1. Okay, if we've heard it once, we've heard it 1,000 times. 1 to any power is 1. Okay, what is 2 to the -1? 1/2. Okay, what's 1/2 minus 1? -1/2. We got a negative times a negative. We got a 2 that goes into 20, 10 times. Answer is 10/3, which, you know, I checked with the calculator. Seems like a long time ago, but anyway, Jessica.
So I was looking at another one of the problems.
Okay, can we focus on this one first? Any questions on this one? Any piece you don't quite get? There's a lot of things that could go wrong here, people, which is Calculus 101. Okay, so many details. Oh, I forgot that. Oh, I forgot my negative. Oh, I should have done this. So there's a lot of stuff that could go wrong. So be careful, take your time, don't try to cut corners on the third problem that we've done ever. All right, now you want to bring a general question to the, or you want to look at number 1? Okay, we're doing one next. Here we go. All right. We're going to do 1. Here we go. Number 1. And then we're going to go move on to notes. X squared plus 2 to the 5th dx. All right. Here we go. What did you use for u? X squared plus 2? All right, so du is 2x dx. We don't have the 2, so I'm going to throw the 2 to the other side. X dx. Okay? All right, now I'm going to replace the x and the dx with 1/2 du. Okay? Then what do I have? U of -3. I'm going out of order because I usually do that last. And I have what? U to the 5th? Okay. So now I have 1/2. What is -3 squared plus 2? And what is 3 squared plus 2? Okay. Now I know my properties. And I know if I'm going from 11 to 11, I'm done. What's my answer? 0. Yes, you should just do that. Okay? Yes, 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 you could. For sure. Okay, so that brings me to this last part of the notes, maybe? Yes, right here. I'm not sure why I have so many pages here. All right. Do you remember the even odd business from pre-cal?
Yeah.
Do you remember that it was like a big deal, but really it wasn't? Okay, now it's a big deal. Okay, so let's take a look at this odd function right here. If f of x is odd, and please note, it's continuous on -a to a. So in that last example, we had -3 to 3, that would have qualified, right? Well, that's where I'm going. Okay. No, if f of x is odd, so this problem, what is definition of an even function? F of -x equals what? F of x. Okay, an even function. I don't know if this is even or not, but a random x and a random -x, either the f of x is the same or it's opposite. What's this? It's opposite. So this one is a odd function. Okay, and odd is supposed to be f of -x equals -f of x. Look at the y's here. These are the y's. One's negative, one's positive. Now you also have functions that are neither even or odd, so this little trick is not going to work. Okay, so on the last problem, let's take a look. The first thing, well, yeah, it was number 1. First thing we noticed is that it has the -a to a. Okay? All right, then we should be saying, all right, wait, let's make sure this is even or odd, because if it's odd, it'll save me a little bit of time. It'll save me all of this. All right, so what we do to check for odd or even symmetry. Negative, both, really. -x squared plus 2 to the 5th. Okay, I plugged in a -x is what I did. That's what we always did last year in pre-cal. Okay. All right, -x is not going to change. What's -x squared? Squared plus 2 to the 5th. All right. Compare. This is -f of x, is it not? Okay, so that means it's odd. So that means when we get this and we say, oh, it's odd, my answer is going to be 0. I'm not even going to work it out. Okay?
Can you re-explain the difference real quick?
It's right here. You plug in -x into that function. If you get the exactly same thing, it's even. When you plug in a negative x and you get the opposite, it's an odd function. You're welcome. Okay. So now it's not quite as nice when it's even. You still have to do the integration. But what happens on the even function, let's check out an even function. Let's do a real easy even function. Y equals x squared. You remember the powers? Even, that's an even function. It doesn't have to have a power of even, but anyway. Okay, so again, let's look at a random x and the appropriate negative x. Check out the f of x's. They're the same thing, right? Okay, so this is an even function. What that means is you have two of the same intervals. Two of the exact same intervals, and it usually is easier to work with 0 than that negative function, right? Okay, so that's the grand plan. Let's look at some examples. Okay, so all these are set up for negative a to a, but again, there's not going to be any flashing blue light that says, hey, you better check this. You got to be aware, oh wait, that's a negative a to a. Okay, so we're going to check to see if x minus x to the 5th is odd. Unless, of course, you're super smart, you already know it already. What is it? It's odd? It definitely is odd because both your exponents are odd, which means it's an odd function, but if you plug in a negative x to check for odd or even, okay, what's negative x to the 5th is positive negative, so this is what we have, right? Now, if you compare this to this, that's exactly the opposite, is it not? So that means it is odd. That means the answer to this guy is 0. I'm done with it. So you take a little bit of time to check out even or odd. If it's odd, you'll be like, woohoo, I'm done. Move on. Okay. All right, now we have this one. All right. Y'all remember the trig functions, which ones are even and odd? Cosine is even, that's right. And of course that makes secant even. But the other two, tangent and sine, are both odd. Okay. So we're checking for even and odd. We know cosine is, what about x squared? So this is cosine of x if it's even. And this is, okay, compare, what do you see? The same thing. So that's an even function. Okay, so now we got to do a little bit of work, but because of the 0 thing, so we're going to change, I'm going to start over. Didn't give myself a lot of room here, so we're going to change this function to be 2 of 0 to pi over 2, the same function. Most people would rather plug in a 0 than a negative pi over 2. That's the grand plan. Okay, that's the even one. It's right here. From negative a to a of f of x. Notice the f of x doesn't change. You're just checking it out to see if it's even odd. The negative a changes to 0, and then we have 2 of them. It's the same idea right here. We got 2 of these guys instead of doing both of them separately. We'll just do 1 and times it by 2. Okay, let's finish it up. All right. So 2, all right, we're looking for an antiderivative. There really, I'm going to change this because it bugs me. There really is no substitution involved here, so don't think, oh yeah, I got to use substitution now that I know that. We had a lot of integration before we started the substitution. So let's see. Eliza, what's my antiderivative? Good job. From 0 to half pi. She was ready. Okay. Now 2 just stayed out there. It's going to continue to stay out there. Okay, now I'm going to plug in pi over 2. So I'm going to have sine of pi over 2 and pi over 2 cubed over 3, which is ugly, but that's okay. Minus, now here's where the 0 is way better. Sine of 0 minus 0. Okay? All right, did I lose anybody in a minute?
So I have a question.
Go for it.
Why is cosine of negative x? Why is that?
Well, this is just to check. I didn't check. This is just to check whether it's even or odd. That's not the function, because that's an odd even function, Lauren. Sorry. That's what an even function is. Remember? F of negative x equals f of x. And if you look at the function itself, the graph of the function, you can see that too on cosine. All right. Yes. Yes. That is, if you would graph this function, it's going to be the same. I don't know what it is. Let's say it's, okay, let's say it's that. I don't know what it is. I don't care. But what happens is from negative half pi, let's say that's over here, to half pi, which is over here, it is exactly the same. So we're just going to say, well, let's just count this piece then twice. So that's the whole idea behind the even function. All right. Now we're ready to do, what's the sign of half pi? 1? Yeah. Okay, so this is 1/3, and then pi cubed over, what's 2 cubed? 8. I just pulled this 1/3, it's right there. Okay, what's the sign of 0? 0, and so that's done. See how nice that was? We don't have a negative pi over 2 cubed, which is going to cancel itself out anyway, so it's all good. Okay. All right, so 1 minus pi cubed over 24. 2 minus pi cubed over 12. Or 2 minus pi cubed all over 24. Either one. Good. Okay. Not pretty, but once we knew pi over 2 was cubed, we knew that was nothing going to happen good with that, right? Okay, so that's symmetry. We got one more over there. What's x to the, we got the negative 4 to 4. All right, is this even or odd? It's definitely odd. So all I'm going to do is squeeze in a 0 here and move on. I'm done. Okay, so the odd is perfect, so you don't want to miss that opportunity to say, oh wait, I forgot about that negative a to anything. Don't forget about it, because it'll save you a ton of work. Especially, you know, even with the half, this is odd. So the function has to be odd if the only exponent is odd. Now if there's a mix, you know, then you got to really look at it. But anyway. All right, I'm done, aren't I? Okay, so go ahead and work on your extra pad out there. Was that my? I'm alone. All right, here's the rule.
It's supposed to snow, and I have to so.
The snow probably all hype anyway.
Every time it's like snow, it never does.
Well, and I'm sure that whoever's in charge of the program is Conway. She'll let you know before that. So,
Yeah, well, she said they won't cancel it, but like, I don't.
well, if the roads are bad, they'll definitely cancel it or postpone it.
Are you doing our humanities or what are you doing?
I don't know, she just said written assessment, so I tested first.
It's not? No. Sorry.
It looks like, which one is that in? That's just a mistake. Okay.
I was like.
Yeah, number 2, the radical should have stopped right there. Sorry. Yeah, I didn't either, clearly.
Really going to fix it.
Okay, let me fix it right now. Now remember, you can check them on the calculator if you really are dying to know.
Only giving me $2.
There, it's fixed. But what are y'all exchanging dollars for?